Hi, I'm Minsoo. I'm going to present monocular depth estimation using Laplacian pyramid-based depth residuals. This is a work with Wonjun Kim in TCVL at Konkuk University. We address monocular depth estimation using deep learning-based method. Our model predicts a dense depth map in pixels from the corresponding single input image. The output image on the slide is the depth map result that came out of our model. The depth map is a visual representation which is widely used to interpret the three-dimensional structure of an image by quantifying the degree of close and distant from the photographing system such as a camera. Pixel intensities directly correspond to depth values. For a case of the image on the slide, the brighter the pixel, the closer it is from the photographing system. Even though deep learning-based approaches show a great ability to reveal the depth layout from only the data, they still struggle to clearly preserve the depth boundaries of objects at various scale levels, since the depth map is estimated only from the final spatial resolution. We propose to apply the Laplacian pyramid to the decoding process for progressively restoring depth boundaries via various scale spaces. Our idea is inspired by the ability of the Laplacian pyramid in successfully emphasizing the difference across the scale spaces, which is highly relevant to object boundaries. Specifically, the encoded features are fed into stacked convolution blocks to generate sub-band depth residuals at each pyramid level. The depth map is progressively restored from coarse to fine scales by combining with the depth residual at each pyramid level. In other words, depth map at each scale level are efficiently restored without additional computational cost, and corresponding depth residual at each level connect scale spaces. This restoration process is greatly helpful to improve the performance of predicting depth boundaries. Here's the example of the depth residual restored at each pyramid level of the proposed decoder. As can be seen, depth properties according to the scene geometry are well revealed in depth residuals predicted at different scales. We calculate the loss only from the final output as an end-to-end manner, so the network internally learns the depth residuals. Training and testing code is available in our GitHub. You can try with your own image to our pre-trained model, or you can train the model from scratch. Thank you for watching this demo.